Hi, my friends. You are welcome to Buti's Math Corner, a place where I make math make sense. Let's try and solve this elegant equation we have on the board. It is 256 raised to the power of x plus x is equal to 0. We are asked to find the value of x. So what we're going to do, if we want to solve this equation, let me write solution. Solution. What we'll do is first of all, subtract x from both sides of the equation. Subtracting x from both sides of the equation gives us 256 raised to the power of x plus x minus x is equal to 0 minus x. This becomes 256 raised to the power of x is equal to minus x. But we'll get to this point. Another task we'll saddle ourselves with is trying to eliminate this x here. And the only way we can do it is to raise both sides of the equation to the power of 1 over x. So if we raise both sides of this equation to the power of 1 over x, we're going to get 256 raised to the power of x to be raised to the power of x. This becomes equal to minus x raised to the power of 1 over x. In indices, if we have a raised to the power of n, m, is something as saying a raised to the power of n times m. So we're going to apply it here. When we apply it here, we're going to get, this becomes 256 raised to the power of x times 1 over x. This is equal to minus x raised to the power of 1 over x. This can cancel this. This equation becomes 256 is equal to minus x raised to the power of 1 over x. So what are we going to do when we get to this point? If we get to this point, what we're going to do is to try and do some substitution or to make some assumption. We can assume that we say let minus y be equal to 1 over x. If minus y is equal to 1 over x, it implies that we can multiply both sides, this equation minus y by x to get minus yx is equal to 1. We can divide both sides of this equation by y minus y. This cancels this so that x will become equal to minus 1 over y. Okay? We can also multiply both sides of this equation by minus 1. This becomes minus x will become equal to 1 over y. So when we get to this point, now we're going to write this equation. But we're going to write this equation in terms of y and not x again. So let's try and do it. This becomes 256 will become equal to, in place of minus x, we know that minus x here is equal to 1 over y. So write 1 over y, replacing minus x. Then 1 over x, we know that minus y is equal to 1 over x. So in place of 1 over x, we're going to put in minus y. Having gotten to this point, we'll also see what we can do from here. In indices, if you have 1 over a, is something as a raised to the power of minus 1. So we're going to apply this here. We're going to apply this one here. So in applying it, 256 will be equal to y raised to the power of minus 1, all multiplied by minus y. Remember earlier we said if you have a raised to the power of n raised to the power of m is something as a raised to the power of n times m. We're also going to apply that law of indices here. When we do that, we are going to get, when we do that, we are going, this becomes 256 will be equal to y raised to the power of y. The reason is that when you multiply this and this, you are going to get y. So you have an equation where you have 256 is equal to y raised to the power of y. But if you check 256, 256 is the same thing as 4 raised to the power of 4. So we can write this equation as 4 raised to the power of 4 is equal to y raised to the power of y. The basis here, the base and the power is the same here. The base and the power is the same here. So we can say that from this, we can say that y is equal to 4. Okay, y is equal to 4. But remember, we are not looking for y, we are looking for x. Our question is not to find the value of y, but to find the value of x. Y was just an assumption we made along the line when we were solving the question. So x is equal to minus 1 over y. We're going to make use of this to get the value of y. So if x is equal to minus 1 over y, then x is equal to minus 1 over 4 because y is equal to 4. So this is the value of x. I hope you enjoyed the question. Thank you very much for watching.